Today we're going to look at finding the probability of independent and dependent events. So what it means to be an independent event, the outcome of one of our events does not affect the probability of the other event. For example, if we have a coin and then this five section spinner, those don't affect each other. So for example, if we looked at finding the probability of spinning a 3 and flipping a heads, we would just take the probability of spinning that 3 times the probability of flipping that head. They don't affect each other, so we multiply them. The probability of spinning a 3, like if we imagine that those 5 spots were numbered, it would be 1/5. Probability of a heads is a half. Multiplying those together, our probability of spinning a 3, flipping a heads would be 1/10. Okay, if we were going to spin the spinner twice, those events are also independent because of what we spin the first time does not affect our second spin whatsoever. So say we want to look at the probability of spinning a 5 and then spinning a 1 on our second spin. We would just multiply the two of those together. We know that each of those probabilities are a fifth themselves, so we have 1 in 25 chances of spinning those particular numbers in that order. Okay, if we have independent events, that means we probably have dependent events as well. So dependent is the opposite of independent. It means that the outcome of one of our events does indeed affect the outcome of the other event. In order to find these probabilities, we're still going to multiply them together, but we take the probability of our first event times the probability of the second event, given that we've already done the first. So we're going to do an example to help us understand what that means. We have 12 blue marbles, 6 green marbles, and 8 red marbles in a bag. We're going to draw our first marble. We're going to keep it out. We might put it in our pocket or set it off on the side, and then we go to draw out our other marble. So because we keep the first marble out of our pocket, now we've changed the number of marbles in our bag, which is going to change our probability. So say we're wondering what's the probability of choosing a red marble, keeping it, and then choosing a green marble second. Well, we know there are 8 red marbles, and there's a total of 26 marbles to start with. And then the probability of choosing a green marble the second time, or the second time we choose, there's still 6 green marbles, but now our total becomes 25 because we've pocketed that first marble that we chose. You could simplify this when we go to solve to be 4/13, and then we can multiply across and get 24/325. You could change that as into a decimal or a percentage, just like we talked about, or you can keep it as a fraction. Okay, so we're going to just decide whether these are independent or dependent situations. So say we roll a 6 on a dice and a 4 on another dice. We have to ask ourselves, does the first dice affect our second dice at all? And the answer is no, which means these two events are independent. What about drawing a red marble, keeping it out, and then drawing a blue marble? Well, that goes back to the example just before this. Since we keep that first marble out, it decreases our total number of marbles, which in turn gives us a dependent event. I want you guys to tell me whether this is independent or dependent. We draw a red marble, put it back into our bag, and then try to draw a blue marble. So tell me whether that's independent or dependent. Okay, here's another scenario. We have 2 squares and 3 circles in a bag. We want to know what's the probability of picking a circle, keeping it, and then drawing another circle. First of all, we have to decide, is this independent or dependent? And based off of the wording, we're going to keep that first circle that we draw, so it is going to be dependent. So probability of drawing our first circle is going to be 3 out of 5. Probability of our second circle is going to now be 2 out of 4 because we've already taken 1 out, so that's why our numerator decreases, and then 1 out of our total as well. We go ahead and multiply those together, so 3/5 times 2/4 is the same as 3/5 times a half, which is 3/10. So we have a 30% chance of picking 2 circles. Okay, find the probability of picking a square, keeping it, and then choosing a circle. So probability of a square is 2/5. Probability of a circle for our second pick would be 3/4. So it gives us 6/20, which is 3/10. Okay, when we talk about probability, we also can talk about odds. And when you hear about odds, that's just going to be a ratio that's expressing the likelihood of an event. So we're going to assume that all of our events are equally likely, and we have favorable and unfavorable outcomes, meaning we have stuff we're looking for and stuff that we're not looking for, we don't really care about. So the odds for an event are our favorable compared to our unfavorable. The odds against would be the opposite. So what we don't want compared to what we would be looking for. So for an example, a bag has 6 red, 2 yellow, and 1 blue marbles. We want to know what's the odds of drawing a red. Well, our favorable outcomes would be any red marble, and we know there's 6. Compared to our unfavorable. Well, in this case, unfavorable would be yellow or blue, and there's 3 of those total. So our odds would be 6 to 3. And remember, ratios are like fractions, so we can always simplify them. We have a 2 to 1 odds of drawing a red marble. How about odds against a blue? Means that we want anything that isn't blue. So that would be red and yellow. There's a total of 8 of them. And then our favorable one would be a blue. So 8 to 1. Okay, here's a probability I want you guys to help me figure out. We have 6 blue shirts in our closet, 4 white shirts in our closet. We have 2 navy pants and 3 pairs of khakis. I want you guys to help me find what's the probability of picking a pair of khaki pants and a white shirt. Okay, we're going to do one more example based off of this information. So say we wore this outfit on Monday. Now it's Tuesday. We threw Monday's clothes in the laundry. And now we need to know what's the probability that I choose khaki pants and a white shirt again. Well, now instead of 3 pairs of khakis, I only have 2. And out of my 4 shirts, I only have 3 in my closet. So I have 2 khakis out of 4 total pants, 3 white shirts out of 9 total shirts. Multiplying those together, I guess you can simplify. 2/4 is a half, 3/9 is a third. Multiplying, we have 1/6 chance of choosing khakis and white shirts again.